Did the first planets come before the first galaxies? It's a question that delves into the very fabric of cosmic history, challenging our understanding of how the universe evolved from its primordial state to the complex structures we observe today. To explore this intriguing possibility, we need to unravel the timeline of the early universe, examine the conditions necessary for planet formation, and consider the potential mechanisms that might have allowed planets to emerge even before galaxies took shape. Our current understanding of cosmic history is built upon the Big Bang theory, which posits that the universe began from an extremely hot and dense state approximately 13.8 billion years ago. In the immediate aftermath of the Big Bang, the universe underwent a period of rapid expansion known as inflation, which smoothed out any initial irregularities and set the stage for the formation of large-scale structures. As the universe expanded and cooled, elementary particles began to form, eventually coalescing into protons, neutrons, and electrons. These particles then combined to form the simplest elements, hydrogen and helium. For several 100,000 years, the universe remained opaque, filled with a plasma of charged particles that scattered photons in all directions. This era of opacity ended with the epoch of recombination, when the universe had cooled sufficiently for electrons to combine with protons and helium nuclei, forming neutral atoms. This allowed photons to travel freely through space, resulting in the cosmic microwave background, CMB, the faint afterglow of the Big Bang that we can still observe today. The CMB provides a snapshot of the universe at a very early stage, revealing subtle temperature fluctuations that represent the seeds of future structures. Following recombination, the universe entered a period known as the Dark Ages, a time of relative quiescence before the first stars and galaxies began to form. During this era, gravity acted upon the small density fluctuations imprinted in the CMB, gradually drawing matter together into larger and larger clumps. The formation of the first stars, known as population 3 stars, marked the end of the Dark Ages and the beginning of the epoch of reionization. These stars were vastly different from the stars we see today. They were incredibly massive, composed almost entirely of hydrogen and helium, and burned through their fuel at an astonishing rate. Their intense radiation ionized the surrounding hydrogen gas, gradually clearing the fog that had shrouded the universe since recombination. The first galaxies began to form as these early stars congregated within larger dark matter halos, drawn together by gravity. These proto-galaxies were much smaller and more irregular than the galaxies we see today, and they grew over time through mergers with other galaxies and accretion of gas from the intergalactic medium. Now, let's consider the possibility of planets forming before these first galaxies. The conventional view is that planets form within protoplanetary disks around young stars, after the star itself has already formed. These disks are composed of gas and dust left over from the star formation process. Within the disk, dust grains collide and stick together, gradually growing into larger and larger objects called planetesimals. These planetesimals then accrete more material through gravitational attraction, eventually forming protoplanets, which can then evolve into full-fledged planets. This process, known as the core accretion model, relies on the presence of heavier elements like silicon, iron, and oxygen, which are necessary to form the solid cores of terrestrial planets and the cores of gas giants. These heavier elements are produced through nuclear fusion within stars and are dispersed into the interstellar medium through stellar winds and supernova explosions. Therefore, the conventional view suggests that planet formation is intimately linked to star formation and the presence of heavier elements, which were not abundant in the early universe before the first stars had a chance to synthesize them. However, there are some theoretical scenarios that could potentially allow for planet formation even before the first galaxies. One possibility involves the formation of planets directly from the primordial gas in the early universe, without the need for a central star. This scenario relies on the fact that the early universe was almost entirely composed of hydrogen and helium, with only trace amounts of heavier elements. Under certain conditions, these primordial gases could collapse directly into dense clumps, forming what are known as direct collapse black holes. These direct collapse black holes could then be surrounded by a disk of gas and dust, similar to a protoplanetary disk. However, in this case, the disk would be composed primarily of hydrogen and helium, with only a small fraction of heavier elements. Within this disk, planets could potentially form through a process called gravitational instability. Gravitational instability occurs when a region of gas becomes so dense that its own gravity overcomes the pressure forces that are trying to keep it from collapsing. This can lead to the rapid formation of massive clumps of gas, which can then contract and cool to form planets. The key to this scenario is the presence of a mechanism that can efficiently cool the gas in the disk, allowing it to collapse under its own gravity. In the early universe, the primary cooling mechanism was molecular hydrogen, which can radiate away heat and lower the temperature of the gas. However, molecular hydrogen is easily destroyed by ultraviolet radiation, which was abundant in the early universe from the first stars and quasars. Therefore, for direct collapse planet formation to occur, there would need to be a region that is shielded from this ultraviolet radiation, allowing molecular hydrogen to survive and cool the gas. One possibility is that these regions could be located within dense clumps of dark matter, which can absorb ultraviolet radiation and protect the gas within them. Another possibility is that the gas could be cooled by other mechanisms, such as collisions with dust grains or the presence of small amounts of heavier elements. Even a tiny amount of heavier elements could significantly enhance the cooling rate of the gas, making it easier for gravitational instability to occur. If planets could form in this way, they would be vastly different from the planets we see today. They would be composed almost entirely of hydrogen and helium, with only trace amounts of heavier elements. They would also be much more massive than typical planets, potentially reaching masses of hundreds or even thousands of times that of Earth. These primordial planets could have played a significant role in the evolution of the early universe. They could have acted as seeds for the formation of larger structures, such as galaxies and supermassive black holes. They could also have enriched the surrounding gas with heavier elements through their own internal processes, paving the way for the formation of later generations of stars and planets. Another scenario that could potentially allow for planet formation before galaxies involves the formation of small, dense clumps of dark matter known as primordial black holes. Primordial black holes are hypothetical objects that are thought to have formed in the very early universe, shortly after the Big Bang. These black holes could have formed from the collapse of large density fluctuations in the primordial plasma. If these density fluctuations were large enough, they could have overcome the pressure forces and collapsed directly into black holes, without the need for any prior star formation. Primordial black holes could have a wide range of masses, from tiny fractions of a gram to thousands of times the mass of the Sun. If they exist, they could have played a significant role in the evolution of the early universe. One possibility is that primordial black holes could have acted as seeds for the formation of galaxies. As the universe expanded, these black holes would have attracted surrounding matter through their gravity, gradually building up larger and larger halos of dark matter and gas. These halos could then have collapsed to form the first galaxies. Another possibility is that primordial black holes could have formed planets directly within their accretion disks. Accretion disks are swirling disks of gas and dust that form around black holes as they accrete matter. These disks can be very dense and hot, and they can provide a fertile environment for planet formation. Within the accretion disk of a primordial black hole, dust grains could collide and stick together, gradually growing into larger and larger objects. These objects could then accrete more material through gravitational attraction, eventually forming planets. The planets that formed in this way would be different from the planets that form around stars. They would be orbiting a black hole rather than a star, and they would be exposed to intense radiation from the accretion disk. However, they could still potentially be habitable if they were located at the right distance from the black hole and had a protective atmosphere. If planets could form around primordial black holes, they could have been the first planets in the universe, predating the formation of galaxies. These planets could have played a role in seeding the universe with life, or they could have simply been ephemeral objects that eventually succumbed to the harsh conditions around the black hole. The idea of planets forming before galaxies is certainly a speculative one, but it is not entirely without merit. There are several theoretical scenarios that could potentially allow for planet formation in the early universe, even before the first stars and galaxies had a chance to form. These scenarios rely on the unique conditions that existed in the early universe, such as the abundance of hydrogen and helium, the presence of dark matter, and the potential for direct collapse black hole formation. While these scenarios are still highly uncertain, they highlight the possibility that the first planets may have formed much earlier than we previously thought. Further research and observations are needed to determine whether these scenarios are actually viable. Future telescopes, such as the James Webb Space Telescope, may be able to detect the faint signals of primordial planets, providing us with valuable clues about the early universe and the formation of the first planetary systems. The search for primordial planets is a challenging but potentially rewarding endeavor. If we can find evidence of planets that formed before galaxies, it would revolutionize our understanding of the early universe and the origins of life. It would also raise profound questions about the nature of planetary systems and the potential for life to exist in unexpected places. In conclusion, while the conventional view is that planets form after stars and galaxies, there are theoretical possibilities for planet formation to occur even before the first galaxies. These scenarios involve direct collapse of primordial gas or planet formation around primordial black holes. These early planets, if they existed, would be vastly different from those we observe today, composed primarily of hydrogen and helium. While highly speculative, the existence of pre-galactic planets could have profound implications for our understanding of the early universe and the potential for life beyond Earth. Future research and observations are crucial to determining the viability of these scenarios and unraveling the mysteries of the early cosmos.